So, if you take, so the magnets have two sides, the south and the north. And if you take a south and a north, they will attract to each other. And if you take a north and a north, or a south and a south, they will repel from each other. So with the magnets, we're going to be using, so we're going to be trying to see, if with the cereal to see if it can attract to the magnets. And we're going to also be using regular magnets to see if it can attract to a magnet. So I'm going to be I'm going to put a boat on the water and see if it goes to south or north, and it's going to be like a compass. This side I think is north and that side I think is south. And then if it goes to north, that means it attracts more stuff, and if it goes to south, that means it attracts more stuff.
All right.
And so if you take a south and a north, they will attract to each other, and if you take a south or a north and a north, they will repel from each other.
All right, let's see that. Is it working?
Attract to each other, and the north and a north or the south and the south will they will repel from each other, so they won't stick together. That, and if you take a north and a south, they will attract to each other.
All right, thank you very much.
With these magnets and with the cereal, we have to see which one can get onto this magnet. So first we're going to see with the cereal. It doesn't go onto this part of the magnet. And then with these magnets, there's a couple of magnets that go onto this red part. I'm going to be doing the car part. So you take this, and it makes the car move.
Science. Very good. Anything else? Here it is. I think it's great. Thank you. You got a whole shot of that.
And the G stands for gravity, the O stands for oxygen, the L stands for their names, Laura and Luana, and the D stands for my name, Espina.
So my hypothesis, my question is, do pennies change when left in a bath of soda overnight? And I thought that regular soda would have a greater effect because of sugar in it, but Pepsi actually had a greater effect because of the phosphoric acid in it. Phosphoric acid eats away copper oxide, which is made after a while when copper is with air, and phosphoric acid eats away copper oxide. And it eats away the copper oxide, which makes them shiny because copper oxide makes it dull, and it makes it shiny.
And so what happened?
So all the copper oxide got eaten away. So those were in Coke, and they didn't become as shiny as those because of in Coke there's less phosphoric acid in it than there is in Diet. So in Diet it became shinier than it would have in regular soda.
Hi, my name is Sarah, and my experiment was, can a potato generate electricity to a light? And it can. So first all you need is like zinc, a zinc plate and a copper plate, and some alligator clips. So for the first potato you connect the alligator clip for the negative one onto the light, and on the last potato you connect the positive to the light, and then you turn the light on and it will light up.
Yay. Good. Thank you very much. Swings it very carefully.
Hi, my name is Lauren, and our project is Do People Associate Shapes with Colors?
And how did you work that out?
So we asked people what color would you color a triangle or a circle, and all shapes. And we learned that most people chose red for an octagon because of a stop sign, and yellow for a star because of the stars in the sky. And we didn't know really why rectangles and squares, so yeah, we surveyed about 30 people.
And this represents all of them?
Yes.
Very good. Thank you.
You're welcome.
Hello, my name is Allison, and I did viscosity.
Okay, and now tell me about that.
So we put a jug of maple syrup in water, and every 2 minutes we dropped a penny to see if it would drop faster. And viscosity is the state of a liquid being thick. So we hypothesized that as temperature increased, the viscosity would decrease. So we found the average drop time, and it did decrease. So we concluded that our hypothesis was correct.
Hello, my name is Ryan, and we're going to be talking about density of liquid. The purpose of density in liquid is to compare liquids of different densities. And I thought that chocolate syrup is denser than water, but less dense than corn syrup. As you see here, there's water, chocolate syrup, and corn syrup. So my prediction was right. These are all the densities of baby oil, olive oil, water, corn syrup, and chocolate syrup. Chocolate syrup was between water and corn syrup, so it must be between 100% and 133% density.
Hello, my name is Richard, and this is my project, Blowing Up with Pop Rocks. In the project, we put the Pop Rocks in the balloon, and then we put it on top of the soda, and we either have a hot soda, room temperature, or cold soda. And then when we put the balloon on the soda, the molecules and carbon dioxide would rise up into the balloon to see how big the balloon would get.
My name is Sam, and our project was blowing up with Pop Rocks. With the boiling soda, the balloon blew up more because the molecules could expand more because they're already moving in the balloon. But with the cold soda, the molecules in the balloon would move slower, and the balloon wouldn't expand as much. We did experiment 3 times.
Did you have 3 different results or the same result?
3 different results, except for the boiling.
Thank you. Thank you very much.
Hi,
My name is Michael, and the project that I did was household glues. So my question was, what household item would make the best glue? And so after that, I got 8 items that I would choose: maple syrup, candle wax, honey, marshmallow, soap, shampoo, and grape jam, and there's one other one, but I forget it right now. And so what I did was I researched all the items to see how well they might make glue, and then I took it and I made a procedure, and then I actually tested the experiment. So what I did was I put all the items on cardboard and with paper over them with their labels on it. And then, so I let one dry for one day and then another one dry for another day. So one dried for 2 days and one dried for one day. And then I took the glues and measured it with this machine right here. And this tells how much force it took me to rip the paper off. So how I did that was I put binder clips on. I put binder clips on the paper that was holding the glue, and then I'd attach this to the binder clips and then pull it off. And the winner for both days was maple syrup. Maple syrup held the strongest for both experiments. And then marshmallow was in second for the first day, and then grape jam was third for the first day. And then for the second day, grape jam was second for the second day, and marshmallow was third. And so then I wrote up a quick conclusion and then a why it matters sheet, and then I just explained the variable I used and the models I had.
Oh, thank you very much.
You're welcome.
Hello, my name is Daniel, and this is my science fair experiment. So my experiment was what would happen if you poured certain liquids into dry ice.
And what did you do?
So me and my dad drove to buy it, and we bought 5 pounds of pellets, and then we drove home so we could start the experiment. I put the dry ice in a bowl, and then I got all of the ingredients, and then I poured it into the bowl, and I took out the dry ice after each pour. I used soda, olive oil, ketchup, water, and coffee.
And what did you find out?
I found out that the consistency and thickness of the liquid matters with the reaction, because the ketchup and olive oil just turn into this weird goop, and that the temperature also matters because the coffee was hot and it was a bigger reaction, and when I used cold water, it was a smaller reaction.
Hello, my name is Grace, and my experiment was how to use physics to win a carnival game. So my problem was how do you knock down all the bottles with only one throw? And how you do it is you have to hit the bottle's center of mass, and the center of mass is a place in an object where if you hit it, the whole entire object or pyramid, in this case, will go back with it.
So my hypothesis says, the center of mass law says that if you hit the bottle pyramid in its center of mass, you are going to knock down more bottles, or maybe even all three. But so I did 2 sets of data, one with pyramid 2, so this is pyramid 2, and with the other bottle on top, that's pyramid 1. And pyramid 2 is what most carnival vendors and other people who do carnivals use, because it's harder to find its center of mass. So in this one, the center of mass would be probably down the bottom because the mass is not evenly distributed. But with the other bottle on top, the mass is mostly evenly distributed, so the center of mass would be more in the middle.
Great.
Hello, my name is Ethan, and my experiment is Kiva Towers. I made up 3 tower designs, and I built them as high as I could with 50 blocks. And then I recorded them. Then I built them on the earthquake simulator. If you pull it, it shakes. And I saw how many pulls the tower could take before it fell down. Then I put a fan next to the tower and put it on the highest setting, and saw how long it would take for the tower to fall down. I figured out that this was overall the best tower because it's the most efficient and is relatively stable. This one is the most stable tower, so if you need stability, you should use this one. And the last tower is overall pretty bad because it's only the second most efficient and not stable at all.
Great. Thank you very much.
My name is Kyla, and my experiment was testing different bacteria, different disinfectants to see how much it gets bacteria to go away. And so I used 4 natural disinfectants. I used water, method, hydrogen peroxide, and vinegar. I used 2 popular brands that have chemicals. I used Clorox and Lysol. And my hypothesis was that the Clorox would work the best because it claims to kill 99.9% of bacteria, and it has bleach in it, which is chlorine. But I actually found out that compared to the other disinfectants, it didn't work the best because it was the first one to grow bacteria, and it grew a lot of bacteria on the agar plate, as you can see right here. And then these are my drawings. On day 3, only number 2 had it, and then day 6 and day 9. And my conclusion, my hypothesis was incorrect because of how much bacteria the agar plate number 2 grew. And then my question was, do disinfectants really kill bacteria and germs as they claim? And are some disinfectants better at killing germs than others?
Hello, my name is Lucy, and my experiment was to test if the type of breakfast food you eat, if it affects your digit span memory. So I did, if it does affect it, I asked many people if they could help me with my experiment, and I wrote a letter to them, and I made a packet like this for every one of them. Then I made a video and posted it on Cluster, and then my hypothesis was I think that the more sugary breakfast foods will decrease the amount of numbers you're able to recite. So then the healthier breakfast foods will increase the amount of numbers. So I made everyone sign a human consent form. Then I gave them the test in a packet. So I made sure that they did it every day, and one member of their family was to tell them numbers and they would have to repeat them. So then I marked it as the averages. So I did the average baseline, and then I realized that I was surprised that Skittles Day increased and then Donut decreased. So then the purple line is the baseline data, which means when they didn't have breakfast. So then my conclusion was that I didn't have enough data to completely prove my hypothesis was correct, but I can make a pretty good guess. If I did it a little bit longer, it could have been correct.
Watered arugula for 21 days with 3 liquids. The 3 liquids are Fanta, Miracle Grow, and water. Just plain old water. So how I did it was every day I sprayed the top or filled the bottom with a centimeter of each liquid, and I did that for 21 days, as you can see. I did my reports, where my data is right there in the left hand corner. So, Fanta died at day 17, just so you know. That's day 16 right there, the day before we threw it out. And I think Miracle Grow grew the fastest. And, well, you mind if you take a taste test? So here is Miracle Grow. I got to my conclusions by watering them 21 days, but I think water tasted the best overall. And Miracle Grow grew the fastest.
Hello, my name is Arati, and we are doing the ice melt challenge. Our experiment is what ice will melt in which container, and our hypothesis was that glass would melt first, then it would be plastic, then paper, then styrofoam. And we thought ice would melt fastest because glass would melt fastest because it has the most conduction of heat, and styrofoam would melt last because it has the least conduction of heat.
My name is Lily, and so our experiment is the ice melt challenge, and we did this because it shows like the conductions of heat, and also that like if you're like if you have an iced coffee, you'd want to have a styrofoam cup because it would melt slower than a glass cup or paper or plastic would. So and we also learned about the conduction of heat.
And what did you find out?
We found out different ways of the melting of the ice, and that glass, it's because when, let's say, like the sweat of the outside of the cup, when you have an ice cube inside of it, it's because it traps, the ice cube traps the most heat, and around it, it makes it cooler.
was what type of Lego structure can best withstand a simulated earthquake? And my hypothesis was I'm testing 3 types of structures. One with thin walls, one with thick walls, and one with thin walls and cross braces. I hypothesized that the structure with cross bracing will stand up best in the simulated earthquake because I've read in my research that cross bracing is a way for structures to survive in an earthquake.
And how did you conduct it, I guess?
Okay, this is design 1. It has thin bricks. This is design 2. It has thick bricks. This is design 3. It has thin bricks and cross braces. And this is the thick bricks, and this is the cross bracing. And the reason my thin bricks is in here is because I had to take apart my thin bricked building to make the cross bracing. But if I just took off the cross bracing, I would have a thin brick building. This video tells what this video shows like all the shaking. My data is the thin walls, its average is 9.248 seconds, and my thick walls is 7.806 seconds, and my thin walls with supports is 16.568 seconds. And this building is actually heavier because thicker walls don't mean that a building is stronger. It actually means the building is heavier, giving it a better chance to collapse. And that's pretty much it.
Hello, my name is Harrison, and my experiment was how does the temperature of the water affect how long it takes to separate the water atoms?
And how did you conduct the experiment?
Well, I had a 9-volt battery right there, and I had 2 wires with alligator clips on each side, and I connected them to 2 pencils that are sharpened on both ends. And I stuck them in cardstock and put the cardstock over the glass of water.
And what did you find out?
Well, I found out from this project that temperature affects how fast you could separate water atoms. When the water was colder, it took longer, and when the water was warmer, it took shorter. When the water was cold, it had less energy in it, making it harder for it to work together with the electrical energy, which makes it take longer for the water atoms to be separated. In conclusion, when the water is hot, it had more energy and it takes shorter, and when the water is cold, it has less energy and takes longer. My name is Jocelyn. My experiment name is Shiny. My proposal is, what question are we trying to answer? We have dirty pennies. We want to make them shiny. We are going to try a lot of stuff to clean them. The question is, what cleaner makes pennies shiny best? My hypothesis is, what is an actual estimate of the answer to our question. My mom uses dish detergent, vinegar, and water to clean things. Lemon juice keeps things fresh. Some people use Coke to clean toilets. I think dish detergent cleans the best. Matters. We need dish detergent, 1/3 soap, 2/3 water, Coke, vinegar, lemon juice, water, 5 clear plastic cups, 15 dirty pennies. This one is, how are we going to conduct our experiment step by step? Place all 5 cups on the counter. Measure out 1 cup of liquid and pour it into a clear cup.
Ready?
I found out dish detergent was the worst one to clean with pennies, and Coke was the best.